When we're building good quality software architecture, what is it we're looking for? If you have a look at the Wikipedia page on this topic, there are a great many abilities that make up quality in software, and in fact in all kinds of systems. Accessibility, affordability, configurability, correctness. The list is endless. And which of them is the most important? Can we prioritize our focus on them, or do we just have to focus on all of them? I want to look at this via a couple of analogies. The first is something you see in UI experiments. When I first came to UI design, I naively thought that when a user clicks on an icon, they do something like this. But it turns out that's not true. If you watch carefully, when people move their mouse up to an icon to click on it, they typically do something like this instead. You see how the mouse here overshoots, circles back in to recalibrate, spirals into a comfort point where the user is satisfied that it is safe, and then they click. This pattern is not unique. It actually happens in a great many contexts. Life goals is another example. I got into programming because I liked the imaginative creativity in computer games. Then I started to get involved in system architecture. This led to mentoring. Mentoring led to finding out more about people, which required more empathy and creative thinking, and so on. My point here is that we never go directly to the end point. The route kind of orbits around it for a while, and meanders while you try things out and learn more. Why do we do this? Because we learn about our environment, and our environment keeps changing while we learn about it. And so we adjust. Let's do a quick thought experiment. We'll build a product. So the question is, what is the best product to build? What will provide the best ROI? It's the one that best meets the needs, right? The thing is, what those needs are is tricky to find because, like with life goals, when you deliver something, it affects the context. Say you have customers who are running an event. They need a system for a single person to sell paper tickets, and so you provide that system. Their problem changes because now their tickets are unique. They need to track their sales. You deliver something using Google Sheets, and this means they can now collaborate, and so they want multiple people to sell tickets simultaneously. You deliver a system to allow sale of digital tickets, and so then their new context means that they want a system that their customers can use to purchase their own. You deliver this, then they need a system to advertise the self-service. You deliver a way to advertise that starts to build an online community around ticket resales, and so on and so on. Every time we deliver something, it changes the context that we delivered to, and so your products need to be refined to this new context. If you're familiar with Eric Ries's book, The Lean Startup, then you will have seen this cycle. It's a flow that lean approach takes to business and perhaps life, cycling over and over through these steps: learning, building, and measuring. You learn about your context and you deliberately use that to build something. Every time you build something, you do so only as an experiment to learn more about your current context. And then you take the measurements from the experiment into your learnings in order to iterate again. The trick is, the shorter the feedback cycle, the more adaptive your business is. We can think of the customer's needs as a target for our business. We know the more accurately we hit this target, the more people will want our products, and so the better our revenue becomes. But this target is not stationary, it's not fixed, it's a moving target. And it's not just because the customer's context is always changing, which it is. Time keeps changing things, and the world is always evolving. But even without that, you see, every time we give our customers a new product, we ourselves are affecting their context. Every system you deliver will affect the customer's own business flow. They will change their processes with the tools that you give them. And so you can never fit their process exactly because their process changes every time you deliver a solution. Because perfection here is not a single point. The problem keeps running forward, and as long as we keep trying to hit it at 90 degrees, we're going to miss it. The solution is to run with it. So this requires a fundamental shift in viewpoint. You see, perfection is not stationary, it is in motion. You don't go to the ballet to watch people stand on the stage. You don't go to the Grand Prix to see the cars parked on the track. You don't go to a skate park to stand on your board. We often see beauty depicted nowadays in static images, billboards, magazines, but it's a limited medium, and perfection itself is not stationary, it is in motion. The creativity, poise, and balance of the skate park is in their activity. The art of ballet is in its movement, grace, interaction. The skill of a jouster or a chess player is shown in their movement. The beauty of nature is in its harmony, continual growth, and interchange. And perfection in software is similar. It is motion, more than static purport. And because perfection is only in motion, we only achieve it via the ability to be in motion, via evolvability. When we can evolve, we can achieve any of the other quality metrics. Without it, we can't. Think about if you prioritize evolvability over, say, securability. The security landscape changes every day. If you can evolve, you can adapt to new security needs. If you prioritize security to the degree that you hinder evolvability, then this limits your ability to adapt. How about readability? If you prioritize readability in a way that doesn't consider evolvability, then your software will only be readable to your current developers. When practices evolve or new hires arrive, it will become labeled legacy, regardless of how readable it is. If you prioritize maintainability in a way that limits evolvability, you won't be able to leverage new systems that are released, and you may prematurely optimize your system toward a set of metrics that your market moves away from. Prioritizing evolvability even above maintainability allows you to adapt as your market changes, and allows you to take advantage of new systems as they are developed alongside your own. And so if evolvability is at the heart of successful systems, how do we foster evolvability? The things that foster systems that evolve are: first is the most obvious, decoupling components of a system so that the individual parts are not held back by their weakest linked items. Also, decoupling your builders via automation. A single contributor is limited by the channel between their formation of ideas and their ability to act on these. Automating and providing tooling increases the impact of a single contributor. Type systems are an excellent example of automating otherwise high-friction contribution. IDEs are another. The way we share information is accelerated by patterns. Without a background in networking, if I said the phrase load balancer to you, it would communicate very little. But if you know what a load balancer is and what it implies for a system architecture, that phrase communicates with brevity a huge amount of information. It's almost like when we have patterns and shared terms, we have a crude version of telepathy. A single term can form a complete construct in someone else's mind, rapidly and efficiently. Shared understanding on patterns, which we can trigger in each other's minds with phrases, greatly increases throughput of interpretation and communication, and also underlies a default alignment. Assertions, for example types or tests, allow you to specify the outcomes before you adjust the internals. This gives a certainty to refactoring and allows us to move faster. These assertions are just as applicable to business process as they are to code. Replacing single points of failure, bottlenecks and silos with regularly retuned processes that can be reviewed, measured and revised. This allows the effect of a single individual or system to be multiplied across many actors. Processes with measures allow business to self-assess and refine their process, where it is much harder to tune an individual or an opinion. In nature's evolution, we see that incremental mutation and allowing this mutation to compete with itself brings improvement. An amplifying effect is seen when allowing a small set of competing ideas to coexist within safe bounds as we explore a moving target. Juxtaposing competing ideas can also bring different inceptions of new ideas too, which would otherwise have been inconceivable. For more information on this, see my other talk, How Ideas Happen. Competition can only happen by surfacing the tensions that play between competing ideas and a self-aware management of these tensions. Feedback loops are critical to aligning with a moving target. Experimentation enables these feedback loops and allows you to gather data as your customer's context evolves. And lastly, communication. This applies to both communicable code and process, as well as open communication between teams. We know that communicable, readable code allows newcomers to understand the domain intent behind and the boundary of methods, and it surfaces the range of outputs, including errors, in a way that is aligned to the domain. But similarly, communication between team members and between teams need to also surface their vulnerabilities, learning gaps, errors and opportunities, evolving understanding, and so enable honesty and curiosity to drive the work between them. Open communication is essential to evolvability. These are the components of evolvable architecture, as much within code and systems as they are between the team members creating it. In fact, you can think of the team members and the code and processes as part of a single evolving ecosystem, gradually aligning with moving customer targets. So what then can hinder evolvability? The first is overbuilding. I want to be quite clear here on what Yagni is, as it's sometimes misunderstood and misused. Overbuilding, or Yagni as it's sometimes called, is when the technology starts to drive without the business need. It is not to be confused with building adaptably or building for a future perceived need. These are both valid. The wisdom that comes from having trod similar ground before should be used. Overbuilding or Yagni is instead where a developer or a product designer or an executive has a plan that they want to enact without having checked this plan's validity via experimentation, communication, or competition. Detritus is all the code or processes that don't serve our current understanding of the customer's current needs. It takes a few different forms. An easy example are manually specified tests, as opposed to automated testing, such as generative testing, compile time assertion, or otherwise. Think about all the times you would have wanted to change public methods to better fit the business needs, but it was like walking through mud, because you then had to update a bunch of arbitrary manual tests. Leaning instead on automated approaches to testing allows the tests to be updated automatically while we are updating a business logic. Similarly, leaning on manually written code instead of solving things at an architectural level adds detritus that needs to be unnecessarily supported. Manually written documentation is another form of detritus. As the system is updated, the documentation has to be kept up to date. Instead, generating documentation and examples, or even better, designing so that documentation and examples are unnecessary, or even building a community that supports the documentation, are far more evolvable and scalable solutions. Detritus takes our time and focus away from the customer needs and focuses it instead on boilerplate, churn, and shifting other manual pipework. And there's one last aspect of this detritus that is not so easy to see because it is often embedded in our dev practices. The peer review tools we have tend to be designed around commit diffs. While this may seem logical for small changes, I see it also encourage devs to put in place guidelines like keep PRs short or simple. The problem with small changes is it is hard to represent fundamental shifts in understanding, and so this results in often leaving old designs in place. Ironically, fixating on small PRs as a dev practice means our code evolves incrementally, but our architecture rarely makes the leaps needed. The underlying thought structures can't change in the same leaps that our understanding of our customer's market. And so code bases get more and more convoluted with the code band-aids over architectural problems that are lagging behind because of small PR practice. Cutting detritus means assessing whether we can drop manually crafted code, but it also means changing the way we communicate about and accept changes to allow for larger architectural changes. PRing via pairing or via whiteboard review sometimes can be more useful. Cargo code is where the understanding behind an implementation fades, but the implementation is persisted in order to ward off unknown issues. The code then becomes a kind of risk in itself, compromising or hindering architectural changes because the root understanding is gone. And the same can happen in business processes. It is vitally important that we maintain comprehension of the rationale behind implementations and processes, so that we can decide when they can be uplifted and in which order. Practices such as code honesty or single responsibility and custodians, cross-functional teams and chapters help communicate and persist reasoning beyond a single employee and allow it to be reassessed. Blocking behavior, dogma, or bureaucracy can also hinder change velocity. One dev practice I came across dealt with this by adding levels to their peer review responses. Green for comments that were informational or could be included in future releases. Orange for issues like readability, which could be resolved after implementation, and red for serious architectural blockers. Only on red would PRs be blocked, and this allowed a greater fluidity of conversation and forward movement in the codebase. Dependencies are an obvious mechanism for velocity to be reduced. All of the components move as slowly as and have the stability of their weakest link. Internal interface contracts or eventing can reduce this and help formalize contracts between services. But unknown dependencies, via mechanisms such as runtime binding or stringly typed API calls, are far worse. IOC magic, mediator patterns, and reflection are runtime bindings, but also invisible stakeholders, like don't change the boss's code, unsurfaced customer needs, and SMEs instead of processes, all represent invisible dependencies on products and code, and need to be actively resolved. Thus too, building on this sense of dependencies, we talk about mental models in software design. But you also need to consider that if unsurfaced, they are unshared, and if unshared, represent churn points, vulnerably surfacing our own doubts about our system rather than trying to bulletproof them before we share them, ensuring that architecture is built on shared understanding and pausing to build these understandings if not, and actively working on our communication skills all help reduce single-person mental models and build shared context. And this may seem a catch-all, but if you're not actively working on the practices that encourage evolvability, then you're persisting practices that work against them. Take stock, check if you're prioritizing refactorability, shared context, and reducing detritus, and you'll be moving much faster very soon. These are the aspects that work against evolvability. In conclusion then, perfection is only in motion, and the most important, the greatest ability in software design is the ability to be able to adapt quickly to changing inputs and make decisions unencumbered by past designs. If you can evolve fast, you can do everything else. If you cannot evolve, you cannot meet your customers' ongoing needs as they change. And the ability to evolve needs to be a constant one. We should always examine ourselves and check, am I able to evolve this system? What can I do to evolve it? Do others understand how to evolve this? The ideal is not stationary, it is in motion. Evolution is the greatest ability.